Hello everyone. Today we are going to start a new chapter, and the name of our chapter is Data Handling. So, what is data handling? Before going or starting this topic called data handling, first of all we should know some prerequisite knowledge about the different types of data, how they are represented. All these things we have to first know it. So let us begin with the introduction. So first of all, we should know what is data. So the data that we'll be discussing here, it has a name, particular name. It's called numerical data. Now what is numerical data? The collection of information in the form of numerical figures is called numerical data. Now by the definition, I know it is not that much clear, so why not let us see an example. For example, say if you are given a data on the number of students who are present in the classroom during a week. So it is given in this form, in the form of a table. So how do we represent this data? We can either represent it in this tabular form or in a numerical form, just by writing down which student is present how many times or in how many days in a week. Or we can also represent this numerical data in a other form, say in a pictorial form. So that form is called pictorial representation of numerical data. We may represent the numerical data through pictures or graphs, and this form of representation of the data is called pictorial representation of numerical data. So basically in this chapter we'll be dealing with the pictorial representation as well as the tabular form of representation as well. So all this comes under the pictorial representation of the numerical data. We'll be dealing with that. So let us see what are the different ways or forms of pictorial representation of numerical data. So first one is a pictograph. By the name itself, something has already clicked on our mind that what it might be. So let us see the definition first of all. Representing the numerical data by picture symbols is called a pictograph. Say for example that in the earlier slide we have seen a numerical data that has been given to us, that is the number of students who were present during a week in the classroom. So say that data is given to you and you are asked to represent them pictorially. So if we represent them pictorially, that means with the help of pictures, then that representation will be called as a pictograph. So let us see another example of a pictograph. Say this is a picture given of a car, and this one single picture represents 100 cars. That means one symbol stands for 100 cars. This is a symbol or a picture, you can say. Now here it is given in which month how much production of cars were there in a factory or in a company. So you can see here in July month it is given 1, 2 and half. So this one single symbol or picture denotes 100 as it is already given to us. So it will be 100 plus 100 and this is half, means it will be 50. So it will be 100 plus 100, 200 plus 50, 250. This represents half of 100. Clear? In the month of August, you can see 3 such symbols are given. So it will be 300. Similarly, in the month of September, 4 are given. So how much it will be? Yes, you're right. It will be 400. So clear what is a pictograph? Just by looking at the symbol of the picture, we can identify our data or the result that we want from the data. Clear? Now moving on, next pictorial representation is a bar graph. So let us see what is a bar graph first of all. A display of information using bars of uniform width their heights being proportional to the respective values is called a bar graph. Means we have to draw some bars, and those bars width is uniform. It remains the same, and their heights will change according to the values that the data has been given to us. You can see one diagram. So this is a bar graph. You can see in the graph paper, when you draw, first of all you have to draw this axis. Along the horizontal axis is the x-axis, and along the vertical it is the y-axis. So you have to write here y, and here you have to write x. It is mandatory. And then we have to do the division. You can see it's given 50, 100, 150. So there you will be seeing some small squares in the graph paper. So we have to count the squares, equal number of squares. Say here to from 0 to 50 there are 5 small square boxes. After that we have given 50. Then again similarly after 5 small boxes we'll give 100. Again after 5 small boxes we'll give 150. So the division should be equal. It should not be 5 boxes here then 6 boxes later on. No, it should be equal. Similarly along this side also, along the horizontal axis, that is the x-axis also, we have to keep a similar gap. Say this gap is 5 small boxes, and this also will be 5 small boxes. This gap also will be again 5 small boxes. So similarly we will continue. And as we know in a bar graph, this width, this distance or this width has to remain same in each case. And in a bar graph, one important thing is that there is a gap in between two bars. These are the bars. Their heights are decreasing and increasing according to the value that has been assigned to them. You can see here bar heights gives the quantity for each category. Means whatever values are being given in our data, accordingly the heights will increase or decrease. And there should be some gaps in between these bars, and this gap will be of equivalent, or you can say uniform. It will be uniform width also, you can say. So this gap also will be of uniform width, and the bar and these bars also will be of uniform width. Clear? Now moving on, the next is double bar graph. Already we have seen just now bar graph. Now what is double bar graph? Now a bar graph showing two sets of data simultaneously is called a double bar graph. It is useful for comparison of data. Same thing like bar graph. The properties of bar graph will be as it is. But here simultaneously two bars will be drawn. Okay, let us see. You can see here. Similarly like a bar graph, same thing. There are similar gaps, similar widths. Everything is same, but you can see here two bars are given simultaneously, two bars, and the colors are also given different just to distinguish between the two datas. So why this is done? This is done if you have to compare two sets of datas simultaneously. Say your marks in a subject this year compared to the last year. So if you have to compare this, then we can draw double bar graph. This double bar graph will give a clear picture of which years how much progress we have done in those subjects. Clear? You can see here some years are given: 2005 to 2006, 2006 to 2007. So both the years data we have compared. So basically for comparison purpose this double bar graph is used. Clear? So I hope you all have understood these three ways of representation, pictorial representation of the datas. You can use these methods for representing any of the datas that has been given to you. Clear? So that's it then. I hope you all have understood. You can again go back to your this textbook. There are some examples given. You can try it out and see for yourself. Try to draw these graphs in your graph copy, and then you will have a better understanding of how to use these bar graphs or this pictorial representation according to the data that has been provided to you. Clear? So that's it then. Thank you and have a nice day.